Greetings. My name is Lakshya Singhal, and then on behalf of my group members Saksham and Nadeem, I will be starting a presentation on the topic of CPU scheduling algorithms focusing on FCFS and SJF. So, what exactly is CPU scheduling? In simple terms, CPU scheduling is the process an operating system uses to decide which of the many ready processes should be given control of the CPU next. The main goal here is to make sure the CPU is used as much as possible while also keeping the time processes have to wait to a minimum. Today, we will be looking at two of the most fundamental scheduling algorithms, first come first serve or FCFS and shortest job first known as SJF. The primary objective of any CPU scheduling algorithm are to make the system feel efficient, fast, and fair to all processes. To achieve this, we aim to reduce three key metrics: the waiting time, which is how long a process waits in the ready queue, the turnaround time, which is the total time from the submission to completion, and the response time. On the other hand, we want to increase CPU utilization and the overall throughput, which is the number of processes completed per unit time. Let's begin with our first algorithm, FCFS, which stands for first come first serve. As the name suggests, the process that requests the CPU first is allocated the CPU first. It's important to note that this is the non preemptive algorithm, meaning once a process has the CPU, it keeps it until it finishes. The entire logic is based simply on the arrival of the process. It just works like a queue at a ticket counter. Now, my colleague Saksham will walk you through a working example of FCFS.
Thank you, Lakshay. I am Saksham Jindal and I will now demonstrate how FCFS work with an example. On this slide, you can see we have four processes P1 through P4 with their respective arrival times and bus time. Since FCFS is based on arrival order, the execution sequence will be P1, then P2, P3 and finally P4. The Gantt chart below shows this visually. P1 starts at time 0 and runs for its burst time of 5. P2 starts right time after at time 5 and so on. Looking at the calculation table, we can determine the completion time, turnaround time and waiting time for each process. By summing the waiting time and dividing by 4, we get an average waiting time of 5.75 milliseconds. Similarly, the average turnaround times come out to be 11.25 milliseconds. Next, let's discuss our second algorithm, shortest job first or SJF. SJF algorithm selects the process that has the smallest CPU burst time to execute. Next, unlike FCFS, SJF can be implemented in two ways: non-preemptive, where the current process finish its burst before the schedule chooses the next one, or preemptive, where a new process with a shorter burst time can interrupt the currently running one. The main goal of SJF is to minimize the average waiting time for a set of process, making it very efficient in certain scenarios. Now I will hand it over to Nadeem, who will discuss the advantages and disadvantages of both algorithms.
Thank you, Saksham. My name is Mohammad Nadeem, and now let's talk about the advantages because both of these algorithms have some really strong points. First, first up, FCFS. Its biggest strength is simplicity. It's just incredibly straightforward to understand and implement, which is a huge plus. On top of that, it's very fair. The processes are executed in the exact order they arrive, so there is a clear and logical order of execution. Now for a SGF, this one is fantastic because it's probably optimal in a very important way. It guarantees the absolute minimum average waiting time for a set of processes. You just can't get more efficient than that. This makes it incredibly effective for batch systems where you want to process a large number of jobs as quickly as possible. So you can see both have some really powerful benefits. Now let's take a more detailed look at the disadvantages of each algorithm. For FCFS, the most significant issue is the convoy effect, where shorter processes get stuck waiting for a long one to finish. This leads to poor performance for short jobs, making it unsuitable for time sharing or interactive systems. Since there is no preemption, once a process starts, all the processes must wait. This can, this can result in a high average waiting time, particularly if long processes arrive early in the queue. Moving on to the SJF, it has its own set of challenges. Its biggest drawback is that it requires prior knowledge of CPU bus times, which is often unrealistic to predict. This can also lead to the starvation problem where long processes may never get the CPU if a continuous stream of short processes keeps arriving. This unpredictability makes SGF difficult to implement in a real time systems, and it's not suitable for interactive systems where a quick response time is critical. These drawbacks are why we need to consider where each algorithm is best applied. First come first serve is used for printers, ticket booking queues, basic batch processing jobs. Shortest job first is used in system where the execution time of a process can be predicted. Batch scheduling and simulations voiceover. To conclude, FCFS and SJF are foundational algorithms in CPU scheduling. FCFS is simple and fair but often inefficient. SJF is highly efficient in minimizing waiting time but is impractical for many real world systems and carries the risk of starvation. Understanding the mechanics and trade offs of these two basic algorithms is essential as they form the building blocks for more advanced and practical scheduling algorithms like round robin and priority scheduling. Finally, here are the references we used for our research, including our textbook by Silberschatz and Galvin, as well as several online resources. Thank you for your attention. We are now ready for any questions you may have.